When evaluating the current draw on a three-phase 480 volt Siemens load center that supplies single-phase 277 volts lighting, it is important to calculate the current for each phase separately. In a balanced three-phase system, current ideally distributes evenly across the three phases. However, because the 277 volts lighting is single-phase and connected to only one phase of the load center, the current draw for the specific phase needs to be individually assessed. To perform this calculation, firstly, use a clamp meter to measure the current draw on each of the three phases, which are typically labeled L1, L2, and L3. Secondly, record the current values for each phase independently. Thirdly, determine which phase is supplying the 277 volts lighting circuit. Calculate the total current draw for the single phase 277 volts lighting by observing the current value in the phase that feeds the lighting circuit. For instance, if the lighting is connected to L1, use the current measurement recorded for L1. It's important to note that the voltage measurement should be taken on a single phase between a phase conductor and neutral, which should read approximately 277 volts. The current measurement should be taken on the same phase on which the voltage measurement was taken to ensure accurate correlation between voltage and current. To ensure safety and efficient operation, it is crucial to properly balance the load center across all three phases. This prevents overloading any single phase, which could lead to overheating, equipment failure, or even fire hazards. Load balancing involves distributing the electrical load as evenly as possible across the three phases. This can be achieved by strategically connecting circuits to different phases to equalize the current draw. If one phase is carrying significantly more current than the others, it indicates an imbalance that needs to be addressed. Addressing an imbalance can involve moving circuits from heavily loaded phases to lightly loaded phases. This requires careful planning and consideration of the loads connected to each circuit. For example, if one phase is supplying a large number of high wattage lighting fixtures, some of those fixtures could be moved to another phase to reduce the load. Another consideration is the type of loads connected to each phase. Some loads, such as motors, can cause significant current fluctuations which can exacerbate imbalances. In such cases, it may be necessary to use power factor correction techniques to improve the balance. In addition to load balancing, it is also important to ensure that the wiring and circuit breakers are properly sized for the loads they are serving. Undersized wiring can overheat and cause a fire, while undersized circuit breakers can trip frequently, disrupting service. The National Electrical Code, or NEC, provides guidelines for sizing wiring and circuit breakers based on the expected load. For example, NEC Table 310.15b16 specifies the allowable ampacities of insulated conductors based on their size and insulation type. Similarly, NEC Section 240.4b provides rules for overcurrent protection of conductors. It is important to consult the NEC and other relevant standards to ensure that all electrical work is performed safely and in compliance with applicable regulations. Furthermore, regular inspections and maintenance of the electrical system can help identify and address potential problems before they become serious. This includes checking for loose connections, damaged wiring, and overheating components. Infrared thermography can be used to detect hot spots, which are often indicators of loose connections or overloaded circuits. By taking these steps, it is possible to ensure the safe and reliable operation of the electrical system and prevent costly downtime. Remember to always de-energize circuits before working on them and to use appropriate personal protective equipment, or PP, such as gloves and safety glasses. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid injury or death. Additionally, when measuring current, ensure that the clamp meter is properly calibrated and that the jaws are fully closed around the conductor. An improperly calibrated meter or a partially open jaw can lead to inaccurate readings. Also, be aware of the potential for magnetic fields around conductors carrying high currents. These magnetic fields can interfere with the operation of the clamp meter and lead to inaccurate readings. To minimize the effects of magnetic fields, try to position the clamp meter as far away as possible from other conductors and equipment. Finally, always follow the manufacturer's instructions for the clamp meter and other electrical test equipment. These instructions will provide important information on the safe and proper operation of the equipment. By following these guidelines, you can safely and accurately measure current in a three-phase system and ensure the proper operation of your electrical equipment.